Okay, a quick video about a method to solve the infinite series. This method is the dilation. Let's make an example. If we have the series we already saw in episode 1 plus 1 plus 1 plus 1, which is equal to minus 1 over 2. I know this is not equal, this is a heuristic method. Check the previous videos. And the question is, but what will be the result of this series? 0 plus 1 plus 0 plus 1 plus 0 and so on. So we dilate all the terms by 2. Quindi, so the dilation factor is 2, and we put a 0 behind every term. So the position is 2, because in every pattern the 1, the number of the first series, is in the second position. 0, 1. The same thing will be, for example, with 1 plus 2 plus 3 plus 4 and so on, minus 1 over 12. The question is, what gives the series 0 plus 1 plus 0 plus 2 plus 0 plus 3 and so on. And the question I explain in this book, which is also available in English. Now I will search the chapter where I explain this. That's fine. Dilation, 2 dilation, 83. Okay, and well, I will use the graphs I made in this book. We saw in the graphs of the normal series, the classic series, this or this, the result is the intersection of the line which cuts through the graph in a particular way with the y-axis, with the vertical axis. For example, let's check again another famous series. For example, in this series, which is 1 plus 1 plus 1 plus 1, there is the line in minus 1 over 2. As a matter of fact, 1 plus 1 plus 1 equals minus 1 over 2. I know this is not an equal, it can be connected to the series, but this is another topic. And the same thing we will do in this graph, but we will make 0 plus, well, the first term is 0, but the null partial sum is 0. So, like in this, we have 0, 1, plus 2, plus 3. Here we have 0, the null sum. Then we have plus 0. Then we have plus 1. Then we have plus 0. Then we have plus 1 again. For example, for this series, I mean. And so on. But if we do the same line with the same method, which cuts through all the middle points of the horizontal steps, we notice that the line goes to minus 1 over 2 again. So we can also then make a compression method to find the result. So we apply the compression method that we already saw in this series. So now it's long, but the method I already explained in an episode. 0 plus 1 plus 0 plus 1. We sum in this way, then in this way we divide by 2, and then we get again minus 1 over 2. So in general, and this is like a theorem, every series which has constant terms like 1 plus 1 plus 1 dilated by 2, or actually, well, let's make for now only 2, has the same value of the original series. So this is the generalization. A plus A plus A plus A, which is equal to minus A by divided by 2, dilated by 2, so 0 plus A plus 0 plus A with the position 2 equals again the same minus A divided by 2. Then we can make other with other series, and we notice that the same thing happens also with 1 plus 2 plus 3, which is equal minus 1 over 12, and then the same thing which with this dilated by 2 in the position 2, which is equal to minus 1 over 12. So the dilation with the position, the 2 dilation with the position in the second term does not change the result of an infinite series. And this can be quite obvious, because one can say, well, all 0 are added, so obviously the result will not change. But later, in episode in future, we will see that, for example, this series 1 plus 0 plus 1 plus 0 is not equal to minus 1 over 2. And this can be very tricky. When I discovered this thing, well, I don't remember, I think it's equal to 0. Let's check. Okay, I don't remember. I will check the list, final list I made. Actually, there are some mistakes in this, some typos. Let's check. Okay, it's equal to 0. 1 plus 0 plus 1 plus 0 equal to 0. And this thing can be really tricky. When I discovered it, I was like, what the fuck? But then I checked with other methods. I intersected with other methods to find if there was no contradiction. And as a matter of fact, there was no contradiction. So the method I developed to find this dilation by 2, but with the first position, was correct. And then we will see in next episodes why this actually is super clear and functional, very true, I mean. Okay, so for this episode it's okay, and see you soon. Bye.